Salt hydrolysis. In salt hydrolysis, here we studied salts of strong acid and weak base. Okay. So if you write examples for salts of strong acid and weak base, we take the examples NH4Cl, ammonium chloride, ZnCl2, zinc chloride, FeCl3, ferric chloride, like this. These are the examples for the salts which are formed by taking strong acid and weak base. Okay. In these salts, if you want to explain about this concept, we take NH4Cl. Ammonium chloride can be taken as an example. So whenever you see ammonium chloride, whenever you take in water, this ammonium chloride can be ionized like this, NH4 plus Cl minus. Okay. In these two ions, NH4 plus, this we get from weak base, and Cl minus, this we get from strong acid. Okay. So whenever an ion we have to get from strong acid, it undergoes complete ionization, but here NH4 plus we get from weak base, it is not completely ionized. That's why it can be involved in hydrolysis process. So here NH4 plus, it can be undergoes hydrolysis with water. So in this, here the compound can be formed like this, NH4OH. After forming this, here H plus ions are present. Okay. So here NH4 plus undergoes ionization, and here NH4OH and H plus is formed. Here NH4 plus involved in hydrolysis. That's why it is called cationic hydrolysis, because here NH4 plus, it contains positive charge. So here the hydrolysis is cationic hydrolysis. That means if you take salt of strong acid and weak base, it involves in cationic hydrolysis. Here NH4 plus is a cation, it involved in hydrolysis. Okay. After hydrolysis, here you can see H plus ions are present. Okay. Within the solution, more number of H plus ions are present. Due to presence of these H plus ions, here the salt, it's having acidic nature. That's why it is called, it is an example for acidic salt, because on hydrolysis, here H plus ions are remain present in the solution. That's why NH4Cl can be act as an acidic salt. So whenever it is an acidic salt, means its pH value can be present as less than 7. Okay. For acids, pH value can be present as less than 7. So here NH4Cl, it can be act as an acidic salt. That's why its pH value is less than 7. Okay. pH less than 7 means H plus concentration can be present as 10 power minus 7. Okay. So here NH4Cl, it can be taken as an example for salt of strong acid and weak base. Okay. So whenever we take salt of strong acid and weak base, here cationic hydrolysis takes place, and in this more number of H plus ions are present. That's why it is having acidic nature. So it is an example for acidic salt. Okay. Right. Now we see. So if you take this NH4 plus cationic hydrolysis, so on reaction with water, it can be formed as NH4OH plus H plus. Okay. Now by taking concentration, here we can explain. Okay. See, first we can write before hydrolysis. That means here hydrolysis is not takes place in that condition. Before hydrolysis, its concentration can be taken as C. Okay. Here C indicate concentration. H2O, it is taken in excess. That's why no need to write about concentration. And initially products are not present. That's why their concentrations can be taken as 0. Okay. It is before hydrolysis. And after hydrolysis, whenever that hydrolysis process takes place, after hydrolysis, here in the place of reactant, it can be present like this, C1 minus H. Here H indicate degree of hydrolysis. So we write C1 minus H, or we can write C minus CH also we can write it. Okay. At the place of product, it is present CH, CH. Okay. So here C concentration, H indicate degree of hydrolysis. Okay. So for this, if you write hydrolysis constant, okay, if you want to write hydrolysis constant for this, here hydrolysis constant, it is represented with KH. While writing hydrolysis constant, product by reactant we have to write. So here in place of product, NH4OH, H plus is present, and in the place of reactant you take NH4 plus, H2O no need to take because it is present in excess. Okay. So it is hydrolysis constant. Okay. So in place of this, after hydrolysis, if you substituted that, KH is equal, here product place CH is present, and in place of H plus, CH is present. Within the denominator, C1 minus H is present. Okay. So here you see one C can be cancelled. So it is present like this, CH square by 1 minus H. Okay. So KH is equal to, we get CH square by 1 minus H. Here KH indicate hydrolysis constant, H is the degree of hydrolysis. Okay, but when you see in the denominator 1 minus H is present, but actually the value of H value is always less than 1. That's why within the denominator we can neglect this 1 minus H. That's why we write KH is equal to CH square, and from this H square is equal KH by C, and from this H is equal to, we write under root KH by C. Okay, it is about relation between hydrolysis constant and degree of hydrolysis. Okay, if you want to write relation between hydrolysis constant and degree of hydrolysis, the relation is H is equal root KH by C. Okay, it is for a salt of strong acid with weak base, and here the hydrolysis is cationic hydrolysis. In this, KH indicate hydrolysis constant and H indicate degree of hydrolysis. If you want to write relation between H and KH, we take H is equal to under root KH by C. Okay, right. After this, here for the salt we want to find pH value also. Okay, for finding the pH value we use some relations. Now you can see what are the relations. Okay, once you see here, if you write formula for KH, that is hydrolysis constant, already we written like this. KH is equal to BOH and H plus, or you take here NH4 plus, we take, okay, NH4OH H plus by NH4 plus. Okay, so product by reactant we write. Okay, right, now we take NH4OH, it is a weak base. NH4OH, it is a weak base. For this weak base, if you write base dissociation constant or base ionization constant, for that product, here the product is NH4 plus and OH minus, by reactant is NH4OH. Dissociation, on dissociation we take base, so base can be dissociated as NH4 plus and OH minus, so we write product by reactant. It is about Kb and it is about KH. Now multiply these two. Okay, on multiplying KH into Kb, on multiplying these two, you see here in place of KH we take NH4OH H plus by NH4 plus, and here Kb is NH4 plus into OH minus by NH4OH. Okay, it is Kb indicate base dissociation constant or base ionization constant, KH is hydrolysis constant. Now we write the relation between these two. You see NH4OH cancel, NH4 plus cancel, so the remaining is here product of H plus concentration into OH minus concentration. Okay, within the solution the product of H plus concentration into OH minus concentration, it is called ionic product of water. It can be taken as Kw. Okay, so from this, if you write a relation between these, you see KH into Kb is equal Kw. Okay, and from this, if you want to find hydrolysis constant, KH is equal to, we take Kw by K. It is also a relation for finding hydrolysis constant. Okay, for a salt of strong acid with weak base, if you want to find hydrolysis constant by taking Kw, that is the ionic product of water, and Kb dissociation constant, base dissociation constant, the formula is KH is equal to Kw by Kb. Okay, right, and see if you want to find H plus concentration according to that ionization, here H plus, it is equal to CH, C concentration, H degree of hydrolysis, and you see C into, here in place of degree of hydrolysis, already we written that in place of H we get another relation, that is KH by C. Here KH indicate hydrolysis constant. Okay, right, now we see here root C is present in the denominator, C is present in numerator. In place of C we write root C into root C, we can written, one root C can be cancelled and one root C is remaining, root C into root KH. In place of these two we can write like this, KH into C. It is about H plus concentration. Okay, now we see H plus is equal to, now what is present, root KH into C is present, and in place of KH we take Kw by Kb, then it can be written like this, in place of KH, Kw by Kb into C we written. Okay, so in place of root I write like this, you see Kw into C by Kb, in place of root I write of. Okay, root means it is nothing but power of, that's why we write like this, it is H plus. Okay, so here we take this H plus for finding pH value. Okay, so here you want to find the formula for calculating pH of salt with strong acid and weak base. So pH, for finding pH, the general formula is minus log H plus. It is the formula for finding pH value. So now in H place we take this. So it is minus log Kw into C by Kb, and within the power of is present. Okay, this we write here. So here pH is equal, it is present like this, minus of log Kw into C by Kb is present. Okay, now you can see it is a log A by B form, and within the numerator AB also present. Log AB means log A plus log B. Log A by B means log A minus log B. On expansion we can write like this, minus of, okay, it is written on outside. Now it is log AB form. So log A, log Kw plus log B, log C, and it is present in the denominator, that is minus. So we write minus log Kb. You can write like this. Okay, right. After this minus I write it within that. Then pH is equal to off, and here you see minus log Kw minus log C, minus into minus plus log Kb is present. Okay, from this you see minus log Kw means it is nothing but pKw. Here log Kb is present, pKb is equal to minus log Kb. Here plus is present, but you write minus. Okay, so you see, so we write a formula like this, of, in place of this we write pKw, and in place of this actually it is pKb is equal to minus log Kb, but here plus is present, that's why we write minus pKb, and here remaining is minus log C. Okay, it is the formula for finding pH of a salt which is formed by taking strong acid and weak base. Okay, if a salt is given, it is formed by taking strong acid and weak base. If you want to find pH for the salt, the formula is of pKw minus pKb minus log C, we have to take it. Okay, right now you see, if it is given at 25 degrees temperature, that means nothing but at room temperature. At room temperature it is given, in that condition pKw value is 14, because your Kw value is 10 power minus 14 mole square per liter square. It is Kw value 10 power minus 14. So at room temperature Kw 10 power minus 14 means pKw can be taken as 14. So here you taken 14. So when you take this off, 14 by 2 means it is nothing but 7, and here minus is minus, both minus are present, we can common that. So we can write like this, 7 minus 1 by 2. Here pKb plus log C is present. It is the formula for finding pH. It is at 25 degrees temperature or at room temperature. We want to find pH of a salt with strong acid and weak base. We use this formula, 7 minus 1 by 2 pKb plus log C. Okay, at normal condition, okay, at any temperature, if you want to find pH for a salt of strong acid and with weak base, the formula we can use is pH is equal to 1 by 2 pKw minus pKb minus log C. Okay, it is about salt hydrolysis. Okay, it is one example of salt which is formed by taking strong acid and weak base. Okay, here you remember the formulas for finding KH. KH is equal Kw by Kb. Here KH is hydrolysis constant, Kw ionic product of water, Kb base dissociation constant. And if you want to find H plus concentration, C into H, by using this H plus we can find pH. For finding pH, it is the formula. If you find at room temperature, this is the formula. Okay, so it is about salt hydrolysis of a salt which is formed by taking strong acid and weak base.